Thanks for joining us for Spa Parts Plus Spa Troubleshooting Video Guides. We have produced a series of tapes to show you the basics of portable spa repair. The systems that you'll see in the tape aren't necessarily representative of the systems that you'll run into in the field. But the methods and the techniques that we'll show you here do apply to virtually every system that's in the field. If you have any questions with regards to the content of these tapes or any of the systems that you run across that we haven't covered in these tapes, feel free to give us a call. We're here to help. I hope that you do enjoy the series, and now, here's Tim.
Every spa owner knows that the right water temperature is critical to a really relaxing experience. It can't be too hot, nor can it be too cold. Now, every spa achieves this by feeding electrical current to a heating element that's immersed in the water. Perfect water temperature is maintained by a thermostat that controls when the electrical current is fed to that heating element. Come on, let's go inside and we'll take a closer look at this system. In our sample system, the heating system is composed of 5 basic components, and those are configured into 2 parallel circuits. The temperature safety circuit consists of the thermostat, the pressure flow switch, and the contactor. The high temperature limit safety circuit consists of a high limit and a contactor. This circuit ensures that the water doesn't reach dangerous temperatures. Each of these circuits has a specific role to play. The thermostat is a temperature-sensitive switch which engages and disengages at an adjustable temperature. The pressure or flow switch ensures that water is flowing through the spa by using either the pressure or flow of water to trigger an electrical switch. The contactor is an electromechanical switch which, when engaged, allows the heating element to receive current. The heating element converts the current into heat and heats the water. And the high limit is a safety switch that reacts to extreme water temperature to shut off the system if the water gets too hot. Since this is essentially an electrical system, we can use our multimeter to trace our way through a working system. And by the way, if you need a review on how to use a multimeter, please see the tool section of tape 1 now. This thermostat is fairly standard for the industry. It consists of a fluid reservoir which is connected to a tube, and that in turn is connected to the bellows, which is housed in the chassis of the unit. Now, when the temperature of the fluid changes, the volume also changes. That forces it to expand and contract, which forces the bellows to expand and contract. That will engage and disengage an electrical switch. And at what temperature the switch engages is, of course, dependent upon the dial setting. Now, the unit itself is supplied with voltage from a power source. When the pressure and temperature fall below the dial setting, voltage is allowed to pass on to the pressure flow switch. Let's take a look here, and you'll see voltage pass through the switch as I turn up the thermostat. And there we go, 120 volts. The pressure or flow switch ensures that water is flowing through the system before the heating starts. One responds to pressure and the other to flow within the heater manifold. Now, if there is adequate water flow, it triggers an electrical switch which passes the voltage onto the contactor. The contactor is an electromechanical switch which causes the high voltage to reach the heating element. The unit consists of an electrical coil that draws together a set of electrical contacts. The contacts allow the flow of the high voltage source to the heating element. The heating element consists of a resistance wire encased in a ceramic-like material called magnesium oxide to form an electrical insulator between the resistance wire and the sheathing. When current is applied to the terminals of the element, the resistance wire heats up and transfers that heat to the water. The primary component in the safety circuit is the high limit. It reacts to high water temperature and breaks the circuit. There are 2 basic types. One is a bimetallic surface, which is deformed by change in temperature and breaks the contact to interrupt the current flow. The other is a fluid type, and it works just like the thermostat to trigger a switch. Once the high limit has broken the circuit, it must be manually reset again before the spa can heat. Now this is how the system should work, but obviously things do malfunction. For the sake of demonstrating some basic troubleshooting techniques, we've altered this model to simulate a malfunctioning unit. And we're going to use this flow chart to help guide us through as we search for the problem. And by the way, you'll find a similar flow chart to this one in the handbook that accompanies this video. We're going to start at the top and work our way down. For our demonstration, we'll say that the system is getting no heat. So the first thing we're going to do is check to see if there's correct voltage at the element. Now, using our multimeter, let's get our leads in here. We'll check the voltage and see what we've got. And in this case, we see no, we don't have the proper voltage. So what do? Well, the next thing we're going to have to move on to is the contactor to see if we have voltage at the line side of the contactor. And again, using our multimeter, we'll check this out here. And there you see we have the correct voltage. Okay, so now we're going to check the coil. We have to find out if we have proper voltage at the coil. So let me get our lead in down here and here. And no, the proper voltage is not there at the coil. Okay, so the next thing we're going to do then is to move on to the line side of the flow switch and see if we have proper voltage there. We'll take one of our leads and put it on the neutral and the other lead on the load side of the pressure switch. And yes, we do have proper voltage at the line side of the flow switch, so we have to ask ourselves if there's sufficient water flow. For the sake of this demonstration, we will say that we have sufficient water flow. And that must mean then that we have a bad flow switch, and to solve our problem, we replace the flow switch. As you can see, different meter readings would lead us on a different path through this flow chart. Now, there are several things that can go wrong with the system, but with careful observation and critical thinking, there's no fault that we can't find in the system. Now, let's take a look at another scenario. This time, the spa is overheating. So the first thing we're going to look at here is the high-speed pump. The constant recirculation of water is sometimes enough to cause overheating due to the transfer of heat from the motor. So we're going to make sure that the pump is in low speed. And we can see now that the pump is running. So what we have to do now is check the voltage at the load side of the thermostat. And again, we'll use our multimeter. And all right, you can see that we have the correct voltage there. Now what we'll do is turn the thermostat down. And we still have 120 volts. So the problem here must be a faulty thermostat that's not shutting our contactor off. Now, let's go out into the field and we'll troubleshoot a real system. Doug Clark here is our spa repair technician. He's going to be working with us on this field repair today. And Doug, what brings us to the breaker box here on the side of the house?
Well, Tim, there's several things we can learn about a spa before we've even seen it just by looking here at the main panel. I have to walk by here to get to the spa anyway, so I might as well learn a little bit about it. What we see here is we have a double pole 50 amp breaker. Now that tells me that the spa is heating on 220. With the 50 amps, it's telling me that it should heat on high speed and that we should have a heat rise of 6 to 8 degrees per hour. That's going to help me with troubleshooting the problem that we'll have back here.
Makes sense.
Yeah, let's go on back to the spa.
Okay, very good.
You bet.
So Doug, what's our problem here?
Well, Tim, our homeowner's complaining that our spa is not getting up to temperature and not reaching getting hot enough. What we want to do is we're going to make sure that we have the proper voltage going to the system so that we do have a 240 volt heater. Now, we're going to reach into the pack and check our line. We'll take our 2 volt leads, go to our 2 lines coming in, line 1 and line 2, and check. And with our voltmeter, we see we do have 240 volts.
Okay.
Now, with making sure that our thermostat is turned up all the way and that we're in the thermostat mode, we can see that with the pump running, it should be heating. So what we're going to do is we're going to find our 2 wires for our heater, which we see come right down into our heater box, and we're going to test voltage there. Now, we'll put it on each line, and again, we should have 240 volts going to the heater, but we don't.
In this case, you're not getting any reading.
That's right, I didn't have any reading there at all.
Okay.
Now, Tim, if I did have voltage going down to the element, but still no heat, what I would have done is taken my amp clamp, placed it around one of the wires to see if there was an amp draw. If I had voltage going to the element but no amp draw, then I know I'd have a bad heating element. But the fact here is I didn't even have voltage going down to the heater. So that's telling me that we have a problem in the safety circuit, whether it be in the thermostat, the high limit, or the pressure switch. Now, since we're in the thermostat mode and we have water circulating, we know that it's not the thermostat, because the thermostat also controls the pump. Previously, I removed the filter to eliminate any restriction there. A dirty filter can create a restriction great enough to disengage the pressure switch down in the heater to make it not want to heat. So I've taken that filter out of there, eliminated that restriction, so I know that it's not a dirty filter.
Okay.
Okay. Now, we've already tested, we have no voltage going down here, so we know it's something in the circuit. Well, I'm going to go down to my heater now and open up this box.
And again, down here, you're checking for what now?
Well, I'm going to make sure that I have line voltage going into the pressure switch and voltage going out of the pressure switch. The pressure switch has to be enacted in order to tell the system that, hey, we've got water flowing through us and that it's okay to turn on. So, I need to find a neutral in the box and go down here to my line in. This is the power going into the pressure switch. I'll look at my voltage tester. Yes, I do have voltage going into the pressure switch. Now, with the pump running and water circulating, we should have the switch. The switch should be activated, and we should have voltage coming out of the switch. So, I put it on the other lead, which is my load out. Looking at my meter, I do not have voltage coming out. So with voltage going in, but no voltage coming out, I have now determined that that is my problem switch. I will replace this switch.
That should solve our problem.
That should solve our problem.
Okay.
Now, before I do anything, I'm not going to reach in here with a live system. We're going to go shut the breaker off. And the other thing is, Tim, I want to make clear, when working with electricity and water and caring for myself, I'm going to go turn the breaker off. I'm going to make sure that this is a safe system to work on. I'm not going to depend on you or the homeowner to go throw that switch for me. It's my liability. I'm going to make sure of it.
And there's no sense in taking chances.
That's right, Tim.
All right, Doug, the breaker is off, so what's next?
Well, we want to make sure that we've shut off the right breaker.
All right.
So we're going to open up our panel again, take our voltage leads, go right to line 1 and line 2, and sure enough, we have no voltage, so I know that we have shut off the wrong breaker, or excuse me, the correct breaker. I have had situations where people have misidentified the wrong breaker, and we've turned off something else other than the actual spa. So it's always good to come back and check it. Okay, now, we need to isolate the heater so that when I remove the pressure switch, the water doesn't keep flowing out. So we have a valve here after the heater that we're going to shut, and we have a valve here before the heater that we're going to shut.
All right.
Okay, now that'll allow us to get into this area. I'm going to remove my 2 terminals so as not to twist the wires. There we go. Now once we remove it, we will have a little bit of water leakage.
There you go.
Actually, that's sealed off pretty good. Sometimes these valves leak. This is our new pressure switch. We're going to check for the same model, yes. And we need to put some tape on the threads, Tim. That way when we thread it back in, we won't have leakage up through the, excuse me, up through the threads and start corroding the inside. We want to put our tape on so that when we tighten it, that it tightens the tape around it. And making sure that I get it in there. There we go, it's nice and tight. We'll put our 2 leads back on the way they were. Our normally open and our common.
And this is probably a perfect example of why you have to make sure that the power's been cut off to this system.
Right. See, I've got water here. If for some reason with that water and all of a sudden the system turned on, and with the new pressure switch in there, that heater could come on and I could have been exposed right there and got a pretty good jolt. So again, we always want to keep safety in mind. That's very important.
Yeah, good idea.
My safety and the consumer safety.
All right.
Okay, we've put our pressure switch back in. We'll open up our valves. There we go. Right. And now we'll go turn our breaker back on, and we're going to test this unit before we go. We've completed our repair, Tim. The power's now back on, and we're going to test the unit before we leave. We want to make sure it's working properly before we leave. Okay, we're going to turn up our thermostat. We hear that our pump is kicked in, circulating the water. We have a heat demand, and our heater should be working. So we're going to now go back to our heater wires. We now have voltage going to the heater. We're going to take our amp clamp. We're going to put it on the reading for a 24 amp heating element. We're going to clamp it around one wire, and sure enough, we're drawing amperage. This is now telling me that the heater is heating. If our temperature sensor is in good shape, it will now heat up to proper temperature, and indeed our problem was the pressure switch.
Very good.
Yeah, we'll have a happy customer now.
All right.
Remember, Spa Parts Plus carries all the products that you've seen in this video. So call Spa Parts Plus at 1-800-521-7587 for a free catalog or to get more information.